Welcome to Brain Vision.
In a previous problem, we were given some original data on cold start ignition times. And that data consisted of the numbers 1.75, 1.92, 2.62, 2.35, 3.09, 3.15, 2.53, and 1.91. Now in this problem, we are given data on the second formulation. So there's still cold start ignition times, but it's a new formulation. And this time, the data includes 1.83, 1.99, 3.13, 3.29, 2.65, 2.87, 3.40, 2.46, 1.89, and 3.35. And what we want to do is we want to draw comparative box plots. So what we're going to first need to do is order our data. So we're going to do the ordered data for both data sets. So for the original data, the ordered data would be 1.75, 1.91, 1.92, 2.35, 2.53, 2.62, 3.09, and 3.15. The ordered data for the second set will be 1.83, 1.89, 1.99, 2.46, 2.65, 2.87, 3.13, 3.29, 3.35, and 3.40. And in order to do box plots, in both cases, we will need the median. And the median is the halfway point of the data. So we are going to use interpolation to determine that. So we're going to do 1/2 n plus 1. And in the original data, we had 8 pieces of data, so n would be 8. So we're doing 1/2 8 plus 1, or 1/2 of 9, which is going to be 4 and 1/2. So what that means is we are going to count to the 4th piece of data, which is 2.35, and then calculate halfway to the 5th piece of data. So we want the difference between those two values. And when you do that, you will get a median of 2.44. We're going to do the same thing for the second formulation. So we're going to do 1/2 n plus 1. But this time we have 10 pieces of data. So we're going to do 1/2 of 10 plus 1, or 1/2 of 11, which gets us 5.5. So that means we're going to count to the 5th piece of data, and then calculate halfway to the 6th piece of data. So we want the difference between the 6th piece of data and the 5th piece of data. So our median for the new formulation was 2.76. Next, we want to find quartile 1, and quartile 1 is the 1/4 mark of the data. So we're going to do 1/4 of n plus 1, or 1/4 of 9, and 1/4 of 9 is 2 and 1/4. So that means we want to count to the second piece of data and then calculate 1/4 of the way to the third. So the second piece of data is 1.91, and we'll calculate 1/4 of the difference between the third and the second. So we get a Q1 value of 1.9125. And we'll do the Q1 or quartile 1 for the new formulation or second formulation. So it's going to be 1/4 of n plus 1, which is 1/4 of 11 in this case, which will put us at 2 3/4. So that means we want to count to the second piece of data and then 3/4 of the way to the third. So the second piece of data is 1.89. We want to go plus 3/4 of the difference. So Q1 will take on the value of 1.965. Next, we want to find Q3, or quartile 3, which is the 3/4 mark of the data. So we're going to do 3/4 of 9 for the original data, and 3/4 of 9 is 6 3/4. So that means we want to count to the sixth piece of data, and then 3/4 of the way to the seventh. So we're going to do 2.62 plus 3/4 of the way, or 3/4 of the difference. So Q3 is 2.9725. So let's do Q3 for the other. So again, it's the 3/4 mark. So we're doing 3/4 of 11. And in doing so, you will get 8 1/4. So we'll count to the 8th piece of data, and then 1/4 of the way to the 9th. So it's 1/4 of that difference. And we will get Q3 to be 3.305. Next, we need to look for any outliers. And in order to do that, we will have to calculate the interquartile range, which is abbreviated as IQR. And you find IQR by doing Q3 minus Q1. So Q3 for the original data was 2.9725 minus Q1 of 1.9125. So the IQR is 1.06 for the original data. And the IQR for the new formulation, or the second formulation, would be 3.305 minus 1.965, or a value of 1.34. So now we're going to look for outliers. We want outliers on the low end. And to do that, we'll take Q1 minus 1.5 times the IQR. So Q1 was 1.9125 minus 1.5 times that IQR of 1.06, and you will get a value of 0.3225. So any piece of data less than that would be an outlier. And as you can see, there's no piece of data less than that, since our lowest piece of data was 1.75. We want to look for outliers on the high end, or the upper end. And to do that, we'll do Q3 plus 1.5 times that IQR. So Q3 was 2.9725 plus 1.5 times the 1.06, and you will get a value of 4.5625. So anything greater than that. And as you can see, there is nothing greater than that since our highest point is a 3.15. So there are no outliers or outlying pieces of data in the original data. Let's look for outliers of the second formulation. So we have outliers on the low end. Again, we're doing Q1 minus 1.5 times IQR. So that's going to be 1.965 minus 1.5 times our IQR of 1.34. And in doing so, you will get negative 0.045. And that means anything less than that would be an outlier. And as you can see, we have no pieces of data less than that. And then we look for outliers on the high end. By doing Q3 plus 1.5 times IQR. So Q3 in this case was 3.305. And our IQR again was 1.34. So you will get a value of 5.315. So anything greater than that would be an outlier. And as you can see, there's nothing greater than that because our maximum is 340. So we're ready to do our 5-number summary so that we can do our comparative box plot. So the 5-number summary is your minimum piece of data, your Q1, your median, your Q3, and your maximum. Again, we need minimum, Q1, median, Q3, and maximum. So for the original data, our minimum is 1.75. Our Q1 was 1.9125. Median was 2.44. Q3 was 2.9125. And maximum was 3.15. For our second formulation, the minimum was 1.83. Q1 was 1.965. Median was 2.76. Q3 was 3.305. And the maximum was 3.40. So we are now ready to take that 5-number summary. We're going to draw a number line. And we are going to start counting at 1.7. So this would be 2.0, and I'm counting by 0.1. So then this would be 2.1, 2.2, 2.3, 2.4, 2.5, and try to make everything evenly spaced. So this is 3.0, 3.1, 3.2, 3.3, 3.4, and 3.5. So we are going to let our original data be in green, and we're going to plot 1.75, which is about right here. 1.91 is about right here. 2.44 is about right there. 2.91 would be just slightly above there. And then 3.15 would be around right there. And what you're going to do is you're going to connect those 5 key points. You're going to draw a box from Q1 to Q3. And then you'll separate the box at the median. We'll put our second formulation. Let's go in pink. And the minimum was 1.83. So that's going to be about right here. 1.965 will be about right there. 2.76, somewhere right in there. 3.305 and 3.4. And again, we'll connect. We'll draw that box from Q1 to Q3. And separate. So there is our comparative box plots. And now we want to talk about this a little bit. We can talk about the more consistent. The original is more consistent. Because it's less spread out. We can talk about the second formulation, whereas greater than (25% of the second formulation is greater than all of the first, or all of the original. So what does that mean? So this here constitutes 25%. So if you look at it here, there's more than 25% of the second formulation greater than all of the data in the original data. We can also talk about the middle 50% of the second formulation, the middle 50% of the second formulation has a larger range than the original. And that was obvious by looking at the IQRs of each one. So the IQR of the original is right here. And you can see that the middle 50% is extensively larger than the original. So there are your side-by-side box plots that you can compare the two different sets of data.